Okay, so now we discuss about quantum numbers. Okay, so before going to know about the quantum numbers, this will define what is an orbital. So orbital is totally different from orbit. Orbit means there is a circular path where the electron moves around the nucleus. Here orbital is actually at first it was given in a quantum mechanical model. So orbital means the region around the nucleus where the probability of finding the electron is maximum, that is up to 90 to 95%. So either a single place law there is no possibility of the presence of electron 100%, means around this is the total imaginary one. So it is the region around the nucleus where the probability of finding the electron is maximum. The nucleus chututa some places the electron move out, okay, but electron movement law, for example, there is some movement like this. So electrons are moving around the nucleus, but the most time spent by the electrons at this place. Okay, just for understanding purpose we are giving this picture. Okay, so around the nucleus, okay, but at some regions the probability of finding the electron is maximum. So example so ee place lo miga places kante electron spend chesina time higher when compared to the others. So that is known as orbital. There are different type of orbitals are present. Okay. And we know that there are different number of types of orbitals are there: S, P, D, F, G, H. But generally we well known about up to S, P, D, F orbitals. Okay. Now, what is the purpose of introducing orbital means? To explain the shape of orbitals, to explain the size of orbitals, to explain the energy of orbitals and the direction of the orbitals, there is three quantum numbers are required. Means the quantum numbers are which explains about so simply we can say the what are quantum numbers means to explain the size, to explain the energy, okay, but to explain the orientation means the direction of orbitals where they lie, size, energy, orientation and even shape. To explain the size, energy, orientation, shape of orbitals, it requires mainly orbitals need three quantum numbers. Need 3 quantum numbers. So what are the 3 quantum numbers? We discuss later. Okay. So again, so already we know in orbitals electrons are present in an orbit, in orbitals. So orbital means generally we discuss it as a box. Okay, electron, in the writing of electron configuration we give the box diagrams. This one box is nothing but called an orbital. Okay, so how many electrons will be present there? 2 electrons. So to know about these electrons in orbitals, need one another quantum number. Now totally how many quantum numbers? It becomes 3 plus 1. They totally now become 4 quantum numbers. Means to explain, to know about the orbitals, we need 3 quantum numbers. But to explain an electron, we need totally 4 quantum numbers. Means only 3 quantum numbers. With the help of 3 quantum numbers, we have some idea about the electrons. Again, to explain the total about electron, an extra quantum number. So this one is extra. This is extra for electrons. Okay, just orbital shape, energy, orientation, size గురించి explain చేయాలంటే 3 quantum numbers necessary. 3 quantum numbers need, that's it. But to explain the electron perfectly, it requires an extra quantum number. Okay. So what are the 3 quantum numbers for orbitals? What are the extra quantum numbers for electron? Now we see. The first one, principal quantum number. Principal quantum number. So it was denoted by letter small n. So it was introduced by Niels Bohr. Here main important. So what is the purpose of the principal quantum number is? So mainly it tells about the size. It tells about the size and energy of orbitals. Energy of different orbitals. It tells about the size and energy of orbitals. So what are the n numbers are? 1, 2, 3. Then the integers. Okay. Positive integers 1, 2, 3, 4 like that. So the one indicated L by L M N 1, 2, 3, 4 K element from inside means from the nucleus. So these are also known as energy levels. Okay. So according to what is the importance of this quantum numbers? This quantum number is energy of an orbital. Energy of an orbital is directly proportional to n, the principal quantum number. Means if an electron is present in n equal 1 and other electron present in n equals 2. So which one is having more energy? Means the electron which is present in n equal 2 level is having more energy compared to the present in n equal 1 electron. and the size of orbital, not only the about the electron's energy, or we can say energy of orbital or energy of electron, both are equal. Size is also proportional to n. Next, distance from nucleus is also proportional to n. Means an orbital is present in first shell. So just for example, n equal to 1 for one orbital, n equal to 2 for an orbital. So energy is higher for second one. The size is higher for second one. Distance is also higher from second one. So distance from the nucleus means these three main factors for orbitals. Energy of orbital proportional to its principal quantum number, size principal quantum number, distance also from the nucleus also directly proportional to the n value. Okay, so by knowing the n value, so there is another important factor. So by knowing this n value, we are able to calculate the number of electrons in a shell. The maximum number of electrons in a shell is equal to 2n square. Means in first shell how many electrons are present? 2 into 1 square means 1. Okay. Just take one example. In first shell, number of electrons how many? 1 square means just 1, that is equal to 2. Same in second shell, how many electrons? 2 square, 4. That is 8 electrons are present in second shell. In third shell, how many electrons are present? That is 18 electrons are present in third shell. In fourth shell, how many? 4 square. That is 32 electrons are maximum in fourth shell. 2 electrons in first shell, 8 electrons in second shell, 18 electrons in third shell, 32 electrons in fourth shell. Okay. So this is the importance of a principal quantum number. Now we see the next one. So azimuthal quantum number. So there is azimuthal quantum number denoted with the L. So it was introduced by Sommerfeld. So what is the main important points here is, so it tells about the angular momentum. Actually its name is also known as orbital angular momentum, or it is also known as subsidiary. It is also known as subsidiary quantum number. Because it mainly tells about the orbital angular momentum. Okay. It determines angular momentum of different orbitals. So we know it is indicated with L. Actually here N values depends on principal quantum number. The L values depend on principal quantum number N. So if generally the L values are given as L values are for an orbital, L values starts from 0 and ends with the n minus 1. Means L values are, simply we can write 0 to n minus 1. Okay. So here important one, it also tells about the subshells. It also tells about the subshells and it also tells about the shape of orbitals. Here very important things in azimuthal quantum number. It tells about the shape of orbitals and about the subshells. Here totally subshells and orbitals are exactly different. Subshells are different and orbitals are different. Okay, so subshells kante subshells lo unde less concept ఏంటంటే ఇక్కడ ఆర్బిటాల్స్. ఓకే, టోటల్ షెల్ లో ఉండే మనకి ఉండే సబ్షెల్స్ లో మళ్ళీ ఉండేవి దే కాల్ ఆర్బిటాల్స్. మీన్స్ ఇట్ టెల్స్ అబౌట్ ద షేప్ ఆఫ్ ఆర్బిటాల్స్. It does not tells about the number of orbitals, it just tells about the shape of orbitals and it tells about the number of subshells and what are the subshells present in a shell. Okay, so it depends on n kabatti oka particular n value lo how many subshells are present. It gives information about that in a particular nth shell how many number of subshells are present and what are the subshells. Okay, now we see about that. If n is equal to 1, okay, if n is equal to 1, we know n starts from 1 only. So L value starts with 0, ends with 1 minus 1 0 means L equals 0 is the last. If n equal to 2, what are the L values? Starts with 0, ends to n minus 1 means 2 minus 1, so 1 is the last. If n equal to 3, so what are the L values? 0, 1, 2 means 3 minus 1, n minus they are starts with 0 ends with n minus 1. ఇక్కడ n equal 3 కాబట్టి 3 minus 1 అంటే 2 తో ఎండ్ అవుతుంది. సో 0 నుండి 0 ఇనిషియల్ పాయింట్, 2 ఇది ఎండ్ పాయింట్. సో మిడిల్ లో మనకి 1 ఓన్లీ పాజిటివ్ ఇంటిజర్స్ తీసుకుంటాం. n equal 4 implies n equal 0. So what is the, it starts from 0. What is ends with n minus 1? Here the n value 4 ends with 4 minus 1 means 3. So what are the remaining values? 1, 2, 3. Okay, so minimum we need to know this one. And as we said, it also tells about the subshells. Subshells, what are the subshells are given? If n equals 0, that is known as S subshell. And important, S is generally S orbital గా ట్రీట్ చేస్తాం. యాక్చువల్గా S is a subshell. Okay, even it contains orbitals also. If L equals 0, sorry, R is 0 completed. If L equals 1, that is known as p subshell, not the p orbital. If L equals 2, that is d subshell. If L equals 3, that is f subshell. If L equals 4, that is g subshell. Okay. And means the L value indicates about the subshells. For example, see, if L is equal to 1, nothing but in first energy levels, how many subshells are present? Only one value is there, only 0 and only S subshell ఉంటుంది. Okay. Same మళ్ళీ ఈ రెండు comparison to write the another one. If N equal to 1, so what are the subshells are present? L is equal to 0, we know that. L equal to 0 means there is only S subshell is present. Means first shell lo only S ఉంటుంది. Even by writing of electron configuration కూడా మనం 1s రాస్తాం. తర్వాత 1p పాసిబుల్ అవ్వదు, 1s is the last. అంటే ఫస్ట్ షెల్ లో ఉండేది ఓన్లీ 1s మీన్స్ L వాల్యూ 0. అంటే 0 is the value, not is the number. L value 0 ఉంటుంది. So number of subshell is equal to number of energy level. Okay, that is S. If N equal to 2, for L value there is a possibility of 0, 1. Means the number of L values is equal to this principal quantum number. This indicates the presence of S and P subshells. If N equal to 3, L equal 0, 1, 2. It indicates the presence of S, P, D subshells, not the orbitals. If N equal 4, N equal 0, 1, 2, 3. It indicates S orbital, P orbital, not orbitals. S subshell, P subshell, D subshell, F subshells are present in 4th level. Okay. Pincer, it tells about the number of subshells. One value indicates one subshell. It tells about the number of subshells. It tells about what are the subshells. Right. It also tells about the shape of the subshells. As the subshell is shape is spherical. The shape of P is dumbbell. Double dumbbell. F is complex. Here complex is not the name of a shape, just it is a undefined shape. Undefined shape kabatti we said it as complex. In importance, why they give the name S, P, D, F means so these are the names given by electroscopic method. Their terms belongs to electroscopic terms and electroscopic is a technique. Okay, then X-ray technique etlago X-ray scopic technique alage. So now write down all these in the form of a table. Actually, the electroscopic terms lo S ante that meaning is sharp. Okay, P is generally indicates principal. So D indicates diffuse. F indicates fundamental. Okay, so this is about the azimuthal quantum number. So one of the very important point belong to this quantum number is already at first we said it is known as orbital angular momentum quantum number or subsidiary quantum number. Means with the help of this we are able to calculate the orbital angular momentum. That is orbital angular momentum is equal to h by 2 pi. root of L into L plus 1. Okay, so in some books it is also given in the place of h by 2 pi, it is known as h bar, root of L into L plus 1. Okay, so this is azimuthal quantum number. Next we see the third one. Magnetic quantum number. So magnetic quantum number, so it is indicated by M. Okay, and it was proposed, nothing but it was introduced by Goudsmit. Okay, what is the importance of this quantum number is, it totally tells about spatial orientation. Spatial orientation, okay, orientation of orbitals. Important orientation means they lie in one direction. ఒక డైరెక్షన్ లో ఉండాలంటే ఏ డైరెక్షన్ లో స్పేషియల్ ఓరియంటేషన్ మీన్స్ ఒక ప్లేస్ లో ఏ డైరెక్షన్ లో మనకు స్ప్రెడ్ అయ్యింది. ఓకే, ఆ స్ప్రెడ్ అవ్వడాన్ని ఏమంటామంటే అది కాల్ ఓరియంటేషన్. ఇక్కడ స్పేస్ లో ద స్పేస్ మీన్స్ ఇక్కడ ఆటమ్ స్పేస్. ఓకే, ఇక్కడ ఆటమ్ లో ఈ టోటల్ స్పేస్ లో, సో వాట్ ఈస్ ద స్ప్రెడింగ్ ఆఫ్ ద ఆర్బిటాల్స్. ఇయర్ ఓరియంటేషన్ మీన్స్ జనరల్ పర్ఫెక్ట్ గా సిమిలర్ మీనింగ్ ఏంటంటే స్ప్రెడింగ్ ఆఫ్ ఆర్బిటాల్స్ ఇన్ ఏ డైరెక్షన్. ఓకే, ఇట్ టెల్స్ దిస్ క్వాంటం నెంబర్ టెల్స్ అబౌట్ ద స్పేషియల్ ఓరియంటేషన్ ఆఫ్ ఆర్బిటాల్స్. అంటే ఏ డైరెక్షన్ లో ఎంతవరకు స్ప్రెడ్ అయినాయి, ఏ డైరెక్షన్ లో స్ప్రెడ్ అయినాయి. సో దట్ ఈస్ కాల్డ్ స్పేషియల్ ఓరియంటేషన్ అరౌండ్ ద ఆటమ్, అరౌండ్ ద న్యూక్లియస్ ఇన్ ఆటమ్. Here main important, the number of orientations of an orbital is equal to number of orbitals, is equal to number of orbitals. It is a very important one. Number of orientation and orbital is equal to number of orbitals. For example, so we discuss this point later after knowing this one. So magnetic quantum number, it depends on azimuthal quantum number values L. So the value starts from minus L and ends with plus L including 0. Okay, minus L to 0 and to plus L. So all values present between these values and between these values comes under M values. Okay, already we know L depends on the N, means M value depends on N and also depends on L. Okay, so for example, if L is equal to 0, that indicates the S orbital, we know that. What are the M values? Minus 0 to plus 0, nothing but only 0. Means there is only one box, one orbital takes place. Means M indicates about the number of orbital, nothing but number of orientations unknown. That is, only one tells S is contain only one orientation. Already spherical shape lo undi kabatti, so X, Y, Z all direction lo same untadi spherical shape ante. So oka direction lo extra spreading anedi undadu. Extra spreading unte that becomes another shape. Spherical shape తీసుకున్నప్పుడు స్పెరికల్ షేప్ అంటే మీనింగ్ ఎక్స్ వై జెడ్ ఆల్ డైరెక్షన్స్ లో హ్యావింగ్ సేమ్ ఓరియంటేషన్ అంటే సేమ్ లెంత్ స్ప్రెడ్ అయి ఉంది, దాన్ని మనం స్పెరికల్ అన్నాం. Means only one choice in a spherical shape. That's why we got only one value, that is one box. S orbital bubbles only one box under S key. L equals 0 also indicates S. If L is equal to 1, what are the M values? Starts from minus L, minus 1, ends with plus 1, including 0. Minus 1, 0, plus 1. Means L is equal to 1 unte already we know what is L equal to 1. L equal to 1 indicates about P. So P is here P. For P orbital we got 3 magnetic quantum numbers, means there is a presence of 3 boxes. The 3 boxes indicates about the orientation of P, the orientation of P subshell in x direction, y direction, z direction. Means ikkada p orbital shape is dumbbell. P orbital shape is dumbbell kabatti so అది x direction లో కొన్నిసార్లు స్ప్రెడ్ అవ్వచ్చు, y direction లో స్ప్రెడ్ అవ్వచ్చు, z direction లో స్ప్రెడ్ అవ్వచ్చు. ఓకే, సో అన్నిట్లో స్ప్రెడ్ ది షేప్ డంబెల్ కాబట్టి ఒకేసారి 3 డైరెక్షన్ లో స్ప్రెడ్ అవ్వడానికి ఛాయిస్ లేదు. ఇక్కడ స్పెరికల్ షేప్ కాబట్టి 3 డైరెక్షన్స్ పర్ఫెక్ట్ గా స్ప్రెడింగ్ ఉంటుంది. ఇక్కడ డంబెల్ షేప్ కాబట్టి ఇది ఒక డైరెక్షన్ లో స్ప్రెడింగ్ ఉంది. సో px ఉన్నప్పుడు 1 ఆర్బిటాల్ గా ట్రీట్ చేస్తాం, పీ వై డైరెక్షన్ లో 1 ఆర్బిటాల్, పీ జెడ్ లో ఉన్నప్పుడు 1 ఆర్బిటాల్. ఓకే, మీన్స్ పీ ఆర్బిటాల్ అంటే డంబెల్ షేప్ ఉన్న దానికి ఎన్ని డైరెక్షన్ లో స్ప్రెడ్ అవ్వచ్చు, పీ ఆర్బిటాల్ కి ఎన్ని డైరెక్షన్ లో స్ప్రెడ్ అయ్యే ఛాయిస్ ఉంది, దాన్ని మనం స్పేషియల్ ఓరియంటేషన్స్ అంటాం. ఇప్పుడు ద నెంబర్ ఆఫ్ ఓరియంటేషన్స్ ఆఫ్ అన్ ఆర్బిటాల్ ఈజ్ ఈక్వల్స్ నెంబర్ ఆఫ్ ఆర్బిటాల్స్. ఫర్ ఎగ్జాంపుల్ పీ ఆర్బిటాల్స్, ఓకే, ద ఓరియంటేషన్ ఆఫ్ ఆర్బిటాల్స్ ఇక్కడ 3 చాయిసెస్ ఉన్నాయి. That's why there is a presence of 3 orbitals. Okay. Let's see. If L is equal to 2, L equal to indicates D. D implies what are the M values now? Start with minus 2, ends with plus 2. What are the including values? Minus 1, 0, plus 1. 5 values. These 5 values indicates 5 boxes. 1, 2, 3, 4. 5 boxes. These 5 boxes are tells about the orientation of d orbital. Sorry, d subshell. అంటే d subshell ఎన్ని బాక్సెస్ లో ఉంటుంది, d subshell ఎన్ని డైరెక్షన్ లో డిఫరెంట్ ఓరియంటేషన్స్ తో ఉందంటే, అంటే ఎన్ని డైరెక్షన్స్ లో స్ప్రెడ్ అయిందంటే dx2 y2, dy square z square, next dx square z square, next sorry, 1 minute. So that is for f orbitals. Actually these are all start from dxy, dyz, dxz, dx square minus y square, dz square. Okay, so these are the 5 d orbitals. If L is equal to 3, last one, that is f. F means minus 3 minus, what are the m values? The m value starts from minus L2, ends with plus L, that is minus 2, minus 1, 0, 1, 2. Total how many are there? 2, 3, 4, 5, 6, 7. 7 boxes are there. Means it indicates that f subshell oriented in 7 possible directions. Okay, అంటే జస్ట్ డైరెక్షన్ అంటే ఓన్లీ XYZ కాకుండా బిట్వీన్ XY, బిట్వీన్ YZ, బిట్వీన్ XZ, అంటే ఓరియంటేషన్ దానికి ఎన్ని టైప్ ఆఫ్ స్ప్రెడింగ్ పాసిబుల్స్ అవుతాయి అంటే 7 టైప్ ఆఫ్ స్ప్రెడింగ్స్ పాసిబుల్ అవుతాయి. కాబట్టి ఇక్కడ దెర్ 7 వాల్యూస్ ఆర్ అబ్టైన్డ్. ఓకే, ఇక్కడ 5 వాల్యూస్ అబ్టైన్ మీన్స్ 5 టైప్స్ గా స్ప్రెడ్ అవుతుంది. ఓకే, So here we can say the number of orientations of an subshell. Number of orientations of a subshell is equal to number of orbitals. For example, S subshell orientations 1. Number of orbitals S lo 1 If L is equal to 1, that is p orbital. So p orbital orientations are 3. Orientations 3 kabatti number of orbitals 3. Here orientations are spreading in different directions. So 5 orientations, 5 orbitals. 7 orientations, 7 orbitals. Okay, this total మొత్తం మన సబ్షెల్ అంటాం. ఈ స్మాల్ బాక్సెస్ మనం ఆర్బిటాల్స్ అంటాం. ఓకే, means to explain about an orbital we need only 3 quantum numbers. So the first 3 quantum numbers are principal quantum number, azimuthal quantum number and magnetic quantum number. So these 3 quantum numbers are necessary to explain nothing but to know about an orbital. Okay, and the last one, it is additional quantum number which requires for electron. Okay, spin quantum number. So it was given by indicated with ms or s. It was given by Lindbergh. So it just tells about spin of electrons in an orbital. It tells about the spin of electrons in an orbital. Means we know that in an orbital there is presence of 2 electrons are present. The 2 electrons generally vary in different directions. So the first one treated as plus half, the second one treated as minus half. Okay, so what is plus half, what is minus half means it indicates about the spin. Okay, there is a 2 possibilities for spinning of electrons around its axis. For example, this normal axis, imaginary axis ki, so electron ela move aitundante clockwise ga move aitundi antunna. The clockwise movement of electron, the electron moving clockwise. So for that electron, S is equal known as plus half, means its spin quantum number is plus half. If around an imaginary axis, electron is moving like this, means anti-clockwise. The movement of electron is anti-clockwise. That indicates S is equal to minus half. I mean there is only 2 spin quantum numbers are there. That is plus half, one is minus half. If electron spins like clockwise, plus half, anti-clockwise, that is minus half. Okay, this quantum number is only applicable for electrons. Okay, so take the all tables and values of different quantum numbers. So now we briefly see about the all quantum numbers. So if principal quantum number is 1, so there is a azimuthal quantum number is also 1, that is only 0. So m, what is the magnetic quantum numbers are minus L2 plus L, minus 0 to plus 0 only 1. Mean it has only 1 box. 1 box how many electrons? 2 electrons. 1 electron is having plus half, 1 electron minus half. Like principal quantum number 2. So there is the presence of 0 S orbital, S subshell, 1 P subshell. S subshell, how many boxes? Box means nothing but how many orbitals? One box. That is one orbital, one orientation. Next for P there is 3. Okay, total 3 boxes, 4 boxes. It contain a total 8 electrons. That is plus of, minus of. There are 3 boxes low, 3 halves, plus halves, and remaining 3 minus halves. In the same way for 3 orbitals. So you need to write the all quantum numbers for if n is equal to 4. So principal quantum number 4 unte. So what are the L values, what are the M values, and what are the S values? Okay.